Hey, hi everybody. Good evening.
Hello, good evening.
Hi Siddharth. Good evening. Hope everybody is doing good. Okay. Is Daneshwar available today? Daneshwar, are you there? Okay. No, fine. Let,
Why Sachin, you're particularly looking for Dhyaneshwar?
he just shared his number. Actually, he was looking for a job change.
Oh, okay.
Yeah, that's why. So I wanted to share news with him. That's why. Nothing.
All right.
Okay. Let me share my screen. Okay. So let's start the today's class. Uh, if you guys remember, we were discussing about the multimodal RAG, and we started with this particular file, which is multimodal RAG. And couple of steps I have already explained to you. What we are doing essentially, we are using a unstructured.io library. Within the unstructured.io, there is a provision that we can go and find it out the title, paragraph, images, tables, each and everything. And this is, in general, we call it as a layout document. So basically we are able to understand the different layouts available in the document, right? And if you remember, we have seen this two main function, which is partition PDF and chunk by title. In the partition PDF, basically this is the function which is going to help us to partition the entire document in a different you can say documents. Some of them are like text, header, narrative text, title. A lot of these things are there. Let me do one thing. I will run this once again. What happened? Hmm, okay, let's just restart this. Hmm. This will take some time, right? If you remember. By the way, anybody tried this code at their end?
Yes, I had run this file and it worked after installing tesseract.
Yes, tesseract is required, and that's why like all of the dependencies, whatever is required, I have already told you. These are the dependencies you have to install it earlier, right? Okay, so the extraction is done, 266 elements. Let's quickly see it. Okay, unique set of documents are this. Sorry, elements, not documents. And this is how they look like. All of this thing, you are already aware of the code. So let me just run it quickly. And here we are performing the chunking by title so that we will be able to get the unique chunk. So we got 33 chunks. Now, you see, if you want to see any one of the chunk, for example, chunk number 2, this is how it looks like, right? We have something called as text, in which the entire text is available. Another chunk example. Okay, it's a chunk number 15 available on page number 7. Fine. Now, if you want to see the all chunks in one go, so these are the all chunks basically. You see, almost all of the chunks are kind of composite, but some of the chunks are, in a table format also. For example, this chunk is only having the table element and not the composite element. Composite element means table, text, each and everything is combined together. Okay, so now what we have to do, once we have our all the chunks available to us, we basically need to create a, kind of, you can say, embeddings out of all of these chunks. And we also have to handle the table chunks as well as the image chunks. And for that, actually, we need a something called as multimodal large language model also. Right now, if you see, in all of our LM, for example, if I go here, over here, we were using this GPT OSS 120 billion, right? Now, this particular model can only accept text and give you the output also in the form of text. But now, for this multimodal thing, let me go here. You see, this time I'm initializing a different model, which is Quen 3.627 billion. Again, it is available on the Grok, but the specialty of this model that this model can take image also as an input, or maybe HTML code also as an input, but that's fine. So basically, it's a multimodal in nature, and we want to use this nature of the LLM. Now, why do we need a multimodal LLM? So the answer is, what we have to do, let's say once we have extracted the tables as well as the images from the PDF, we cannot directly, store those images or tables as it is. What we can do, we can convert those images into a base 64 string and we can store it. That we have already done. Similarly, for tables I've shown you, you can convert it into a HTML table, HTML code, and you can store that. But as a robust pipeline, what we are going to do, we are going to send this data to multimodal LLM, and we are going to generate some kind of description for those images and tables. So along with the table, along with the image, we are gonna also store the, their description in the vector database. Because in the vector database, you cannot store the base 64 image or maybe HTML code. You have to have some kind of embeddings. And to get the embeddings, this is the best way. We'll send these images or tables to the LLM, get some information about those images and tables. Okay, maybe you can call it as a metadata information about those tables and images. And then we are going to store those information into the vector DB. And now whenever a user will ask a question, we'll retrieve those information. And once, let's say, those information will be retrieved, their associated metadata, which is image and table, we are going to retrieve it, and then we are going to send it to the LLM for the final inference in the entire RAG pipeline. So that is what we want to achieve. That's why we need a multimodal LLM over here. If it is not making sense right now, still fine. Let's continue. At the end, you will understand, okay, what I'm trying to say. So let me run this.
Sachin, wonder, sorry to interrupt. So are you saying that in vector database we cannot store the images or the base 64 encoding?
Yes, yes, it's a vector database. So you need to store a vector only. You can't
Yeah,
store the,
embeddings.
yeah,
Okay.
you can't store images or those things, tables.
Okay.
That's it. Yeah, let's continue. I will come to the diagram also. First, I want to give you the whole walkthrough of the code. You will understand automatically. Don't worry.
Okay.
All right. So we have defined our LLM over here. It's the same thing. I just changed the name of the model. That's it. Inferencing engine is same like Grok. Now, I've written one function over here which is called as separate content type. And if you pay attention, what it takes a chunk as an input. And we are creating one dictionary which is called as content data. And it will separate out the text, table, images, and also type of the data. And we are going to store all of the data in this particular format. So this function will check, okay, whether my chunk is having some kind of metadata and original element in it or not. If it is available, then we are going to iterate through all of the chunk. You see, we are just iterating through all of the chunk metadata. And here we are just checking if the element type is stable. In that case, just grab this dictionary content data, and in the types, just update it that, okay, it's a table and actual value of that table. And then finally, if it is an image, we are just going to take once again the same dictionary content data, and we are going to update the image with that. Okay. So you see here, it's a base 64 image, we are updating it. And here it's a table HTML, we are updating it. Okay, that's it. So this function is just going to take your chunk, check whether it has a metadata information or not. If yes, let's iterate through all of the chunks and let's separate the table and images. If no tables and no images are there, that means it's a pure text type of data. So that can go inside this normal text basically. So that we are already doing it by saying chunk.text. And finally, we are just applying a set operation on this content data. Why set operation? Because we don't need any duplicate chunks. Set will automatically remove them. And then finally, we are once again converting back to list. Okay. So ultimately, we need, you can say chunk number 1, 2, 3, 4, 5 into a list format. So that's why finally we are just converting it into a list and we are returning that content data. That's it. So let's run this. Okay. Now this is another function. I'm calling it as a create AI enhanced summary, which is using a Grok LLM, which we have defined earlier over here. You see, this is our LLM. Of course, it's a multimodal LLM. Now, if you pay attention to the prompt, see very carefully what it says. You are creating a searchable description for document content retrieval, and content to analyze is this one. So this is the text content. So for this text content, what you have to do, you have to basically create a searchable description. That's the prompt. Now, this particular function takes three things: text, tables, and images. So this is only purely for text part, right? So for example, if from page number 1, if you have extracted only text, so this will be handled by this particular prompt. But what if the tables and images are also there? So in that case, you see, if table is present, then in the prompt text, we are going to attach this table information. And what we are doing is we are just looping through all of the tables. And now this is the new prompt, which will be concatenated with this particular prompt. Okay. So if table is available, in that case, I'm saying generate a comprehensive searchable description that covers key facts, numbers, and data points from the text and tables, main topics and concept discussed. Question this content could answer a visual content analysis. So actually, I have lot many times iterated this particular prompt, and then this prompt was kind of giving me a good accuracy in order to, so let's say you have a table, you just what we are doing is basically sending this table to LLM, and we are just asking LLM that, hey, this is my table. What I want is basically create a searchable description for this table, but store all the facts figure in a textual format. That's it. So that if anybody asks a question, it should all the data should be present in that description itself. So this is for the table. Okay. Same goes with the image. Now let's say if image is present, okay, if the image is present, in that case, you see, I'm iterating through all of the base 64 images. Okay. And once I have the base 64 URL to me, I can simply send this base 64 to the LLM. Since we are using a multimodal LLM, it can see it. And then we are just going to ask, okay, that this is our image. You just have to create a searchable description, and the same kind of prompt will be available on that also. So that's why we are sending the same prompt text over here, and it will give the final response when you are going to invoke the LLM. So that is how we are handling image, table, as well as text, all the three conditions. And if any exception occur, of course, we are just printing those exceptions over here. All right, now let's do one thing. Let's run this function. And here is the main function. So summarize chunk is the main function, which will take the chunks. I'm creating a blank list over here, which is we are calling it as a LangChain documents, in which we are going to store all of those data. Okay, once it will be processed after the LLM. Then you see, I'm just iterating through all of the chunk. First, I'm calling this separate content type, this function. You see, this function we have already seen. This is what I'm going to do. It will separate all the data into text format, table format, image format. So let's come here. You see, this also takes a one chunk at a time, and this will gonna give us the content data, right? We are just printing some information about the same content data. And if you remember, content data is finally it is a list. Now we are checking if content data is gonna have the table or image. In that case, I have to call this function create AI enhanced summary, right? If it does not have image and or table, in that case, we are going to preserve the original data as it is, because it's a just text based thing. So we don't have to do anything on that. But let's say if it is a table or image, in that case, we are going to call this function create AI enhanced summary. And this function we have already seen. What it will do, it will basically try to create the searchable description for the table and images. All right, and then we are going to update our content data with text, table, and images. That's it. And if any exception is going to occur, we are going to print it over here. Otherwise, it's simply a text data, so we don't have to do anything. We are just saying, okay, content data of text is our enhanced content. That's it. Now, here what we are doing, once we have each and everything ready, so we are calling this document class, and this document is coming from LangChain. So let's go to the definition of this. You see, it's a class document, which is a class of LangChain, and we have already imported it over here. Let me show you. You see, from LangChain core.documents, there is a class called as document. So it's nothing but just a LangChain document. And since you are going to use this, you will be able to convert directly from this document to vectors very easily. and that's why we are using this document. It's simply a list, okay, but it's a LangChain document list, not a normal Python list. Let's come here. Yeah, so we are using this document, and what we are saying that page content is going to be our enhanced content, and the metadata information is this original content, and we are using this json.dumps. So basically it will gonna take the original information, and with the help of this json.dumps, we are gonna dump the text information, table information, and image information as a original content. And this is going to be our page content, which is nothing but our enhanced content. Enhanced content means after applying the AI on top of it, okay, LLM on top of it. And then this is how we are going to get one single document. And you see, we have defined our LangChain document over here, and we are iterating through all of the chunks. So we are keep appending a single document into the same LangChain document, which is a normal list. Okay. But in that normal list, what we are appending? We are appending this doc, which is a type of LangChain document. So in the normal list, we will have at the end all the documents available to us of final document. Okay. And that's it. We are just going to return it after printing the length of the document. Okay. So let's call this function, which is summarize chunks. We are passing the chunks, and let's see what will happen. Okay. So you see it is saying processing chunk with AI summaries, processing chunk 1. Type was text, 0 image and 0 table was found. So it is doing nothing. It is just moving to the next chunk. In the next chunk also, 0 image, 0 table, doing nothing. It is preserving the raw text. Chunk number 3, nothing is found. Let's move ahead. Chunk number 4, nothing is found. Let's move ahead. Chunk number 5, one image was there. So you see now it is calling this AI summary function, and it is creating the AI summary for that particular image, right? And it is also printing, yes, AI summary got created. So we got the enhanced type. Similarly, for each and every chunk, wherever image or text or combination of image and text is found, that chunk will be sent to the LLM, and we are going to create a searchable description for that particular part of the data. So this function will take some time because we are calling actually LLM for each and every chunk. And you see, you will be able to see the output of the LLM also, what LLM is doing. And currently chunk number 13 is getting processed. Okay. Here we have one table. So yes, AI summary got created for this particular table.
Sachin, for image, how it's prepare the chunks? Text that we define, but for image, how it prepares?
No. So you see, it's very simple that what you are doing, you are taking the, let's say, let me open the chat GPT. It's very equivalent that you are taking, any kind of image, providing it over here and asking your LLM, okay, this is my image, just create a searchable description for that image, so that you will have the additional information, or you can say metadata information of the same image, so that at the later stage we will be able to store that information into a vector DB. That's the whole purpose of doing this exercise. Okay. Are you able to get it?
Yes.
Okay.
Sachin, just a while ago we applied this set data structure, right, to create a list of
No. Set is not applied to create a list. Set is applied to remove the duplicates.
Yeah. So are we expecting any duplicate embeddings in that case?
No. It's see, the chunk can have duplicates, right? So let's go
Yeah,
here.
so how chunks can have duplicate? Because the whole document will be unique, right?
You are right. Let me go here. You see, over here we are applying a set because we are checking, okay, if the any document is having this particular metadata information, in our case, of course, you are right that it will not have any kind of duplication. But just to be safer, if this will repeat itself, like let's say if the chunk is having a similar kind of information, by applying just this set function, you can remove the duplicate.
Okay.
If you want to remove this part, it will work. But as a good practice, we are just putting it over here.
Okay, got it.
Yeah. Of course, in one single document, there is a high possibility that you will not get any duplicate chunk.
And
But just to be double sure, that's it.
yeah, yeah. This is
All right, done. So you see, it has processed all the 33 chunks. And wait, somewhere it is failing. At chunk number 32, it failed. And the reason is, you see, it says AI summary failed, a request too large for model. So at chunk number 32, it got failed. It has 3 images in one go, and this got failed. So what's the solution? Simple. We cannot use a grok model over here because for grok, this request is too large. However, I mean, when I have run this earlier, it was able to do it perfectly fine. So in order to, maybe come out of this particular problem, what you can do, you can use any other LLM because I have told you different LLMs you can use. So maybe you can go ahead with the, let me show you. I think we have used the Gemini models. So you can use that Gemini model also. Right now, I'm not going to use any model as of now. But only thing is you just have to change this function. Okay, this particular function you have to change. Instead of using this Quen model from Grok, just use the Gemini model or maybe Azure model, whatever API key you have, you can use that. All right, now let's come down.
Sachin, can we reduce chunk size here?
If you're gonna reduce the chunk size, how you see we only have the 33 chunks. So and that is also we, if you remember when we started the let me go here. When we extracted the unique elements, it was 266, right? So from 266 elements, we come to 33 chunks. Now, when you say, okay, I have to reduce the chunk size, just think, okay, if you're going to reduce the chunk size, meaning you are removing some information, right? So you're going to lose those information. And the problem over here is not occurring due to chunk size. It is occurring because we are sending the 3 images in one go. And before that also, we were calling the Grok LLM, and Grok as a free tier platform, you will be only able to make some certain number of calls in a 1 minute. And that's the problem happening. So either you can have a cool down time in your code so that after 1 minute you will, take only that chunk and you are gonna hit it once again, and probably you will get the output. Or otherwise, you can just use any paid API key and you will get the answer. Okay. Yeah.
One more thing. We are doing image and getting the description of image. So in VectorDB, are we saving again that description along with the link that this description belongs
We'll come to it.
specific
We'll come to it. Okay. Let's continue. Now let's just try to print the process chunk because we have called this function, and if you remember, this function is going to return us a process chunk. So let's try to print this entire process chunk. And there you go. We have all of our 33 documents or chunks available. And you see, it's a type of what? It's a type of document. So document is what? It's a Python, it's a LangChain document. And above, it's a list. So inside a Python list, we have multiple LangChain documents. Now, let's try to see one of them. So I just printed one of them. And if you see in this document, you have a metadata equals to, this is a dictionary where you have a original content. This is your raw text. So this is what you have extracted from the first chunk, okay, as a raw text. Now let me open the PDF also side by side. All right, so these kind of information we have extracted in the chunk number 1. And if you pay attention, it's the same kind of information like Google research, USZ. You see, Google research. And let's go to the very start. It says this 2023. 2023 is coming, I think, from here, this part. Okay. Anyways, whatever the part is coming, it's fine. Google hereby grants permission. So
GPT 5.6 tera. GPT 5.6 tera.
what is this text? Let's find it out.
It is the header on the top. If you go on
It's a
the
header. Yes, it's a header. Okay. Yeah. You're right. So yeah, it is able to extract this part properly fine. And let's go to the very end. And you see, it has this information. This chunk does not contain any HTML file or neither any image file or image base 64 basically, or neither any HTML tags. So hence this chunk is only a pure textual chunk, and in that case we are gonna have this raw text only. That's it. Now what I'm gonna do, so I'm gonna run this function which is called as export chunks to JSON. What it will do, basically, it will iterate through all of my chunks and it will dump it in a JSON file format. I have already done it. So let's go here, or let's do it once again. Okay. Now you see it has created this file called as chunk export.json. Now let's open this and let's see how it looks like. Now you see you have your chunk ID 1. This is your enhanced content. This is your original content. So you see in the metadata, you have the original content. Now, whenever there is no HTML and base 64 images, in that case, raw text and enhanced content will be the same. Okay. Because we have not done any enhancement. Enhancement is done only when we have the HTML and base 64 are available. What do I mean by enhancement? We are sending those data to LLM to create a searchable description. That's the enhancement. So let's go down and see chunk number 2. Of course, this is also a same. Okay. Yeah. Now here you see this particular chunk number 5, chunk ID 5. This is the enhanced content. And let's come down. You see, this is your original content. In the original content, this was the raw text. It does not have any table, but if you pay attention, it has one image, and this is the base 64 of that image. You see, it's a very huge string. Let's not go into that because we have already discussed it. Now, you see, the raw text is only this much big. After sending this image to LLM, and then we have added that information in this raw text. So now when you see this enhance content, you see it has a lot of other information as well. Now you see over here, this is the AI generated output that the user wants a searchable description for a document containing this. Now why we are getting this? Because we have used a reasoning model like Quen, and whenever Quen gives you output, it will also gives its reason in the output. ideally the reason should not be available, right? I mean, there is no benefit of putting the reason also in the searchable description, because that is not a data, it's a noise. And when you are gonna create the vector for this content, a lot of noise also will go into your data. And hence, whatever LLM we have used right now for creating the searchable description is not good one. So what we'll do, we'll first understand the entire code and we'll just change the LLM and rerun it once again. Okay. And I wanted to purposefully kept this. Maybe I mean I have could done the homework and then directly shown you the good part, but I wanted to show you that depending upon your LLM, you might be able to get this kind of information also, which is a reasoning trace of LLM. We don't need a reasoning trace. We only want the final output of the LLM. So you see the final output starts from here. You see, analyze the text content, and this is the model architecture. So it has basically, this was the image for this one. Let's go here. I think yes, it's a this particular image, right? And for this image, it has created this kind of that. Okay, it has a architecture in which encoder decoder is there, a lot of other information, basically add and norm layer, feed forward layer and whatnot. Okay, so basically based upon the diagram, LLM has created some kind of description which got added to the raw text. Okay, so now we have the enhanced content which we will be able to use. Now imagine that, let's say somebody asks you a question um, related to this particular diagram, that okay, in the decoder, how many blocks are there, okay, in the decoder layer of the transformer architecture. So since we have this information now, and we are going to create the embedding of this entire information, so we will be easily able to first of all get the this relevant chunk. Okay, now this still not solve the entire problem, because this is just only a half of the equation, but at least you just understand, okay, we are able to get the a proper chunk for the asked question. Now once we get this chunk, along with this chunk, enhanced chunk, what we have the this base 64 image also available with us. We cannot store this base 64 in the vector database, correct, but we can have it attached as a metadata. So when we are going to extract the relevant chunk, so along with the relevant chunk, we are going to send this picture both in a LLM call, and then we are able to get the proper answer. That's what we wanted to do. But let's say if you don't create this searchable description, you won't be able to first of all find it out the correct chunk from your data itself, right, or from the vector data itself. So that's why we are doing this particular process. Yeah, Manas, just wait. Okay, I will complete and then you can ask your question. All right, so till here we are able to understand that all of our chunks are now ready. Now let's move ahead. I'm gonna use this Google Generative AI embedding as a embedding model, and we are gonna create a chroma vector database. So this is a function, create vector store. And you see we are using this Gemini embedding 001 model, which we have already seen. This chroma code, you are already aware of it, how to create a chroma vector database. You see we are sending all of our documents over here. It takes also a persistent directory. So we are giving a persistent directory name as dbv1 slash chroma db. Anybody can answer why dbv1? Because we have already created database of folder for one of our class. So that's why I'm giving a different name like database v1, okay, for this one. So let me delete the older database one. Okay. And it takes this embedding model, persistent directory, and the collection metadata. It should be always HNSW space cosine. That's it. So let's run this. And now it is gonna send all of the chunks one by one, and it got created like vector database. Embedding is too much fast, so that's why it won't take much time. Okay, so that's it. Now let's try to ask a question. What are the two main components of the transformer architecture? Okay, and we are gonna retrieve it, like we only gonna retrieve 3 documents, and then finally we are gonna export that as a JSON file format. That's what we are doing over here. Let's run this, and there you go. We are able to get the chunk ID 1, 2, and 3. This chunk talks about the encoder and decoder stack. This chunk talk about think the user want a searchable description. So if you remember, this was our chunk number 5, right, from the original chunks, which has the description of that encoder decoder block. But you see, this is not a very useful information at the start, because this is a LLM, reasoning trace. Of course, we are gonna remove it later, but right now this is fine. At least we are able to get the output. And you see, this particular chunk is also having this image associated with it, or base 64 image. All right. And then chunk ID 3, let's see what it is talking about. The goal of reducing sequential computation also forms the foundation. All right. This is talking about the encoder block within the encoder block, but the original question was not, the what is available inside the encoder block. So it is somehow related. That's why it is giving. You can also check the scores also, right? We already have seen how to check the scores, similarity score, but that's fine. At least 2 of the chunks are sufficient enough to give us the answer. And since we are calling this function export chunks to JSON, you will be able to see the all the information in a JSON format. You see, this is the rag result.json. So this is how we are able to retrieve the proper chunks. Now, this is the function which will take the entire code from the above. Basically, this function partition document, then create chunks by title, then summarize chunk, and then create vector store. So it's a complete pipeline. When you are going to run this, all the above code will run, but we have already run it. So I'm not going to run this part of the code, but you understood, right? It's a complete pipeline. So this is how just you have to call all of your function, and that's it. Your vector database will be ready. Now let's come over here. Just wait, guys. Okay, just 2 to 3 minutes. Wait. Now let's say this is my query. How many attention heads does the transformer use, and what is the dimension of each head? Anybody, by the way, remember the answer for this question? We have learned the transformer. 8. Yeah. So let's see what we are able to get, and let's first understand this entire pipeline. So first of all, we are gonna send this query to our vector DB so that we will be able to get the chunks. So here we are getting the chunks, and then finally we are writing a function generate final answer, which is gonna use the LLM. Of course, it will take the chunks as well as query, user query. Now, in the prompt section, what we are doing, we are saying based on the following document, please answer this question. All right. And then we are iterating through all of the chunks, and we are checking in the chunk metadata, do we have the original content or not? If we have the original content, then we are gonna just convert it into a JSON format. That's why we are calling JSON.loads, because it's initially it's a dictionary. You can very well convert the dictionary into a JSON format. And then we are checking that within that, do we have a raw text or not, this particular field. Now, if anybody is not able to recall, so let me show you. You see, you have an enhanced content, and then within the metadata, you have the original content and then raw text. You see, this is how your chunks looks like. So that's what we are checking over here. And Finally, we are saying if raw text is available, then my prompt text is going to be text, just a text, and then just combine this text with this raw text. That's it. So in the prompt text, we are going to combine this. Prompt is already we have written based on the following document. Please answer the question. That's it. And here is our query. And then finally, one text will be coming. And then we are checking in the original data, table HTML tags are there or not. If table HTML tags are there, so just in the same prompt text, just say tables and then iterate through all of the tables and then combine the table data also in this table section. Okay. Similarly, and then the prompt text will become like this. Please provide a clear, comprehensive answer using the text, table, and images above. Images, are we handling images? Let's see. Why we are not handling images over here? We should be doing this for images also. Okay, I think it is here. Yeah. So this is finally going to be our message content. That type is text, and text is nothing but your prompt text. And finally, what we are doing, we are once again iterating through all of the chunks to check whether we have a image URL as a base 64 image or not. If that is also there, we are going to combine that also in the, we are going to extract it, this base 64 images, and we are going to combine it with the message content, which is coming from here. This is the list of our message, which we are going to finally send to the LLM. So in this message content, we are going to append the base 64 image URLs as well. And that's it. Finally, our entire message content list is ready to send to the LLM. So we are just converting it into a human message class, this entire message content as a human message. And finally, invoking that LLM is going to give us the response and we are just going to print it. That's the entire pipeline. Okay, so let's try to test it on this particular question, that how many attention heads does the transformer use? Let's run this. Okay, we got the answer, and let's try to understand what is available in the answer. So you see, again, this LLM is giving us the thinking trace. Okay, it's a reasoning model. We are using Quen model, and it always starts with this special token called as think. There is a way you can stop printing these traces, but currently I didn't have stopped that. I wanted to show you that yes, this is a model which is gonna give you these kind of traces also in the output. So it always starts with this special token called as think. So here it is all thinking. Okay. And finally, you see the thinking got closed over here. So from here to here, the model was just thinking, doing the calculation, thinking everything. But the final answer is available in just one line. Based on the provided document, the transformer uses 8 attention head, h equals to 8. The dimension of each head is 64, and they're right, which is calculated by dividing the model dimension, which is 512, the number of heads, and so on and so forth. So these are the information. And you see, this is a correct information. We are able to understand, yes, transformer uses 8 head overall. So this is how we have tackled our data. Now, if anybody have any question, please go ahead. And then what we'll do after answering your question, we are going to run this entire pipeline once again, but we are going to replace the LLM. We will have a proper LLM without any reasoning trace, so that we will have a very good chunks. And those chunks will be, we are going to once again reference it. Yeah, now please go ahead.
So Sachin, that thinking process that you described at the end, so can it be called as chain of thought prompting?
No, it is, you are not doing it on a prompting. It's a reasoning model. That's what I'm saying. There are two type of model. I have already told you, right? In the large language models also, now some of the models are not a reasoning model, meaning they don't do any reasoning internally. But there are advanced models like Opus 5, Quen model, and then DeepSeek models. You talk about GPT 5.6. So these are all reasoning models. So they internally reason and then they are going to give you the output. And these kind of models are very good for creating the agentic workflows. So if you're dealing with some normal workflow like GenAI workflow, you don't really need a reasoning model. What you need is, I mean, if your model is normally fine, if it can do some kind of, normal, you can say understanding of the language, it is fine. But let's say if you are building a agentic AI system where you have to call multiple tools, or maybe you have to call another sub agents. So in that case, a reasoning model will have a advanced reasoning. It will able to understand, okay, I have attached to these many tools. So, and at which given condition I have to call which tool. So that is called as a reasoning model. It's not a chain of thought prompting. Yes, you in a way you can say these models are trained on those kind of data where you have all. For example, let me give you one particular example. You will understand how these models are trained. Let's go to this one. So in order to train the reasoning models, it's a very simple one, but only the thing is, for example, let's say you have a one particular question over here, or maybe one sentence in a one single row, and then you will have answer for that over here. So let's take one mathematical example. Let's say if somebody asks you, okay, what is LCM of 4 and 6? Okay, let's say this is your question. What is LCM of 4 and 6? Now, a normal model, which is not a reasoning model, we will directly provide the answer. Okay, whatever the LCM of 4 and 6. Let me check 4 and 6 LCM.
12.
12. So we are going to write it over here, directly the answer. Now, these kind of LLMs like GPT-4o mini or maybe GPT-3, 3.5, these kind of LLMs are not reasoning LLMs. Nowadays, all the LLMs are reasoning LLMs. So they are directly trained on the answer. So maybe just in the answer pair, someone will write, okay, LCM of 4 and 6 is 12. So this is your one data point. Now imagine you will have billions of data points and then you can train your entire model. But when it comes to reasoning LLMs, the only change they do is instead of directly showing the answer, they give steps. So instead of writing in this way, they will say use a special token reasoning, okay, which we are also seeing in the output. And then they will start writing the reasoning steps. So in order to calculate the LCM of 4 and 6, we start writing the table of 4 and 6, right? So we basically, LCM stands for least common multiplier. So they will explain the entire concept of LCM, how LCM itself works. Now, when they write the LCM, so basically they will also write these kind of, school grade mathematics steps. So that is like, let's say 4 and then 6. So LCM is least common multiplier. So basically, they will start, writing these steps. For example, so 4 and then in table of 4, we have 4 and then 8, right? Then 12, 16, and so on and so forth. Similarly, in the table of 6, you will have 6, 12, 18, and so on and so forth. Now, if you go over here, so what is the common number, which is also a least common number? Basically, you will get a lot of common numbers, but this is the first number, which is least common number, common between table of 4 and 6. And this is how we calculate the LCM. So they write the entire reasoning steps over here, and then when you are gonna feed the billions of data like this, LLM will also able to understand, okay, this is how they have to reason one by one. And that's the only difference between reasoning models and normal, you can say, LLMs. And since Quen is a reasoning model, we are able to see this kind of traces over here. Hope you got the answer.
Yeah.
Yeah, can we say these models as React models then in that case?
React is a pattern, right? It's a agentic pattern. Have I
Okay.
taught you React as of now?
No.
Yeah. So React is basically reasoning plus act. It's a loop. Okay. It's a agentic pattern. It's not a reasoning LLMs. Reasoning LLMs are used inside the React pattern agentic loop. Okay. We'll talk about it.
Okay.
Sachin, you mentioned about the reasoning model, so definitely the reasoning model would take more computational power and
Yes.
because wanted to go for the effective result generation. So do we have
Correct.
any specific comparison where we should always go for reasoning model or where we can go for the basic LLM?
When that's what I'm saying. So let's say whenever you are building a agentic AI system where multiple steps are combined, okay, in that case, going or opting for the reasoning LLM is an obvious choice. But if you have to just call one or two tool, okay, or maybe just a simple workflow kind of thing. I mean, it's a Gen AI project. RAG is what? It's a Gen AI problem statement, right? But here we know that, okay, what have to be done after each step, right? So here you are not connecting multiple steps with the LLM, but rather than steps are faced. So in this case, there is no need of obvious reasoning model. You can always go with the normal models also.
Yeah, so somewhere just correct me if I'm wrong. Like the reasoning model is basically used for the validation purpose. Is it correct or
Which purpose?
reasoning model is used for the validation purpose. I mean, LLM is already trained,
Mhm.
but just using the pipeline concept to train or give the, quick result rather than go for the effective result. So that's the reason we are going for the reasoning model. Is it correct?
See, reasoning model, why we are going it, so that we will be able, earlier, this problem actually originates from the mathematics perspective. So when a normal LLM was trained and people started asking a mathematical question like what is 4 into 3, these kind of basic question, a normal LLM was able to give a proper answer. But when they start asking some calculus problem, right, some integration derivative problem, over there it was directly giving the answer, but it was wrong. Now people started worrying, okay, it is giving the answer very confidently that the integration of this maybe sine function should be this much, but it was not giving the proper reason why the answer is this. So they started thought, okay, as a human being, when we do a step by step process, there are more chances that you will reach to the final answer accurately, right? Because you are doing a step by step process instead of directly interpreting the result. So that's why people started building this kind of reasoning model.
Got
That's
it.
it.
Thank you. Yeah, yeah, sure. Thank you.
Here
Sachin,
people are talking about this thing, right? Reasoning model, Sachin. Is that something multimodal RAG is, implemented through reasoning model only or
I mean,
normal?
multimodal RAG is a different concept. Don't be confused. See, when I say reasoning model or any kind of model, it has to do with the data. The way LLMs are trained in a different ways. If you remember from my previous lectures also, I told you different company uses different strategies to train their LLM, right? Some might use decoder, some might use encoder. Now someone has come up with this concept also that let's train the model in this way that it will have a very strong reasoning. So it has nothing to do with the multimodal RAG. Multimodal RAG is a concept, right? Multimodal means what? Modal means type of data. So you basically, when you say multimodal, means it can support text, it can support audio, video, images, whatnot. So these kind of data. And RAG, you have already know, it's a retrieval augmented generation. So when you say multimodal RAG means now you want to support multiple data in your RAG pipeline. Now in order to build a RAG pipeline, the final part is LLM, right? Where retrieval augmented generation. So generation is done by the LLM. Over there, you use any LLM, a reasoning LLM or maybe non-reasoning LLM, doesn't matter. I mean, if it is a simple RAG pipeline, I would suggest going for the normal LLMs instead of reasoning LLM. So that's the difference. Don't be just confused and combine the multimodal with reasoning. There is no relationship between multimodal RAG and reasoning model. Okay.
Yeah. People started discussing this thing, so I thought
No,
it
because
might be relevant.
I
Yeah.
people why I started discussing, because I use a Quen multimodal reasoning embedding model. Okay. So
Okay.
multimodal model means what? It can support audio, images, those things. That's the only meaning of multimodality. That's it.
Okay. Okay. So I have one question related to multimodal RAG. So here we created this thing, right? Enhanced chunk, right? Enhanced data from the original data, right? And the difference only comes when we have some data related to your table or might be related to your images. Then only the data gets changed for the enhanced data, right?
Correct.
Enhanced data, I have seen the data in enhanced. You only showed us, right? So it contains some textual data, right? I mean, images are converted to your base 64 encoded data. It's just for maybe while retrieving the data from.
While retrieving the data, we are gonna use this particular field, enhance content, because vectors are made up of this particular part. Okay, but there is going to be always association. So association means what? That this image base 64 is attached with chunk ID 3, correct? So when you are gonna retrieve this part, now you know, according to this list or this JSON file, that this particular content is attached with this image base 64 or this HTML. Now once you have this data available, you have retrieved the proper chunk. Now you are going to take that chunk, as well as if image or HTML table is present, you are going to take this and you are going to send both the information to the LLM for the final answer of your query. Okay.
Yeah, but while fetching the similar chunk, it uses the original
Only
content, right?
text. No, not the original content, enhanced content.
Sorry, enhanced content, right?
Yes. Yes.
The base 64 data is just sent to the LLM just for maybe
Final generation. Yes.
maybe user want that particular image to be displayed or something like that.
No, not for that purpose. I mean, you can use for that purpose, but you see why we are sending that image as well as this textual data, because you have, let's say, you have enhanced this content for one of the image. Let's go to the chunk number 5 where image is also present. So yeah, let's say, so this was your raw text, which is very small. Now you have used this image, asked the LLM to enhance this, and we got the above information, this one, right?
Right.
Now, let's say you are only going to extract this information and you are only going to send this much and not this image to the final LLM. So what will happen? This is right. I mean, since it's a searchable description, at the very first time, LLM might have extracted all the information, but it does not have the context that what user is basically asking. It has extracted as a in general information from that image, right? But at the end, what we are doing, a user is asking a question that, okay, how many blocks this particular maybe architecture uses. Now LLM is having the context, and it is very much possible that while enhancing this content or this content, LLM does not have captured that information. Okay, that is very much possible. So that's the reason we are taking this chunk as well as the final image along with the user query. We are sending to the LLM so that we will be able to get the final answer. If we are not going to send this image, it is very much possible that you will not have that information alone in this content,
Enhanced content.
enhanced content. It is vice versa also possible that information was present, but how does it matter? Because you see, you are just sending extra information which is related to the same document, right? So even if you are sending two pieces of information, LLM can be double sure while giving the final answer, right?
Yeah. You
And that's
also told
why,
us. Yeah.
and
Yeah. Go
that's
ahead.
why this kind of strategy is kind of production ready strategy which you can use directly. It's not a simple strategy, right? You are
Yeah.
extracting, first generating the enhanced content, taking it, finally you have the image or table also, and then you are sending it. So now there is a high chance that your LLM will not hallucinate, rather it will give you a proper answer.
Yeah, the final response would be more
Yes,
accurate in this. I
yes,
understand. So
exactly.
you were also saying, Sachin, the enhanced content is created through the LLM.
Yes, through the
Right?
LLM, correct.
Where is that code? I mean, I just missed out that piece.
Here it is. Let me
We
show you.
call the LLM at the end, right?
You see, uh, this function summarize chunks.
Yes.
So first of all, we are iterating through all of the chunk. We are calling this function separate content type so that we will be able to understand, okay, HTML tags are there or not, images are there or not, text are there or not. So this function will do that. We are just printing it over here, and you see over here, we are checking it and calling this function create AI enhance summary. And when I go to this, you see here we are using our LLM, large language model.
Got it.
Here we are checking if it is have a table or not, if it is having an image or not, and accordingly we are invoking that LLM and getting the enhanced summary over here as an enhanced content. Yeah.
Got it. Yeah, thank you.
Yeah, Sachin, one final doubt, sorry. So I have a doubt on the chunking technique. Maybe from previous session, we did discuss about the partition PDF and also the chunk by title chunking
Yes.
technique. So right now, I believe you used partition PDF in the beginning, and we got maybe 267 elements. And later, I think you chunked it by chunk by title of this
Correct.
unstructured IO, and I believe you got 33 elements
Correct.
based on title. So, is there any reason we decided to use this chunk by title, or am I missing on something?
No. So there is a reason, yes. See, partition PDF is doing what? It is just gonna partition a lot of things, right? Basically, it will, you see the elements, it has a lot of text, header, narrative text, title,
Yeah.
lot of things basically. If you want to see all of them, you see it has figure, image, footer, everything. Now let's go to the PDF. You see 206 chunks, meaning what? One chunk is only having, let's say, title. Another chunk is, let's say, only having this
Footer.
footer. So do you think this one chunk is this much is sufficient to, basically create the vector database? That's not a good strategy. Once you have this entire chunks, don't you think it's a good strategy that whatever is coming inside one header or one title, let's combine them, right? So let's say if this is the title, within this title, whatever is coming, all this information, why not to combine them? In that way, you will have one bigger chunk which will have preserved the entire context also. So that's why we had to go after having this. You see, we are finally checking, okay, what are the only title elements category wise. So we found out, okay, total 25 titles from this entire document, right? So total in the entire PDF, we have 25 titles. And within those titles, you see, this is one of them. Now, what we are doing, we are here like tables and all of these things. Now, within those 25 titles, you will have footer, header. Title is, you can imagine a bigger kind of umbrella, and within that, a lot of things will fall into that. So we have uh, finally used this chunk by title so that we will be able to combine a lot of the chunks, and finally we got this 33 chunks. And when you combine it, then it becomes called as composite element, because you have now combined header, footer, and all of those things into a title chunk. That's a strategy we have used. Yes.
Okay. Thank you. Thank you so much.
Yeah, no
So,
problem.
so just one follow-up question on the same.
Mhm.
Suppose we think we have, large table or suppose large image. Sorry. Then what will happen when we say the splitting? Let's suppose we say, okay, just take the 2000 max. But in this case, does image or table get split up as well? If yes, then there is a, you know, uh, overlap or something there, strategy as well.
No. So, what's your question? I don't understand. Can you please come
So,
again?
yes. So basically, I'm saying that even in this strategy, we say that, okay, max size for the chunk is 2000. But suppose we have a large table,
Hmm.
table with large amount of data, and it is not possible to feed it in 2000
Where you are
characters.
seeing this 2000? Can you tell
Max
me?
character 3000.
This one, right?
Yes.
So this is a hard limit, okay? What it says, never exceed 3000 character per chunk. So let's say one title, and then within that title, header, footer, whatever is coming. So we are only gonna keep keep going to the 3000. Now let's say if you have a very high PDF, doesn't matter. Let's even if you have a very huge PDF, does not matter, because ultimately we want a good amount of chunk which can be converted into a proper, you can say, searchable description at the end, right? And finally we will be able to create the vector embedding out of it.
Correct.
So even like it is a 3000, you see there are two more parameters, and what it says, new after n character is 2400. So it says try to start a new chunk after 2400 characters. So there is going to be little bit overlap also between this 3000 2400. So 600 is going to be the overlap. And also this third parameter, what it says, combine text under n characters, which is 500. So for example, if there is a tiny chunk which is left and which is having within the 500 of limit, 500 character of limit, we are going to take that chunk and merge it with the same chunk. So these two, you can say, smart parameters are also there. So if some small chunks are, leaving here and there, we are going to take it and combine within the same chunk.
Sorry, just to repeat my question. For text, it's fine, but suppose, as we said, right, we have table, we have images. But
Table and
suppose,
images are segregated differently.
got it. So it's always together, even if you, because
Yeah.
my question was more on table, like uh, text is
Yeah.
fine, we can overlap. But for table, suppose it's a large table. Like, for
No,
example,
it
we
will
have
it
10
will not break
characters.
it in between. It will always
Perfect.
have this table. You see, when you are gonna have this composite element, you will also have these tables, right? So
Perfect.
that
It
is,
makes sense then.
yeah, yeah,
And I mean, that was good doubt. If the table images are not, it's get split up, it will not make sense. So
definitely.
until unless,
Yeah, definitely.
perfect. Thank you. That was simple.
Yeah, no problem.
One question, Sachin. So while let's suppose we were developing this pipeline and we use some sample PDF to understand how it works,
Mhm.
and for this specific PDF, you showed that you got an error while processing three image continuously for the QN model.
I'm gonna now fix it. Don't worry about it. Yeah.
Sure. Yeah. So here we got it somewhere here, but let's suppose we were doing something in testing and we tested on most of the PDF, it worked fine. But in production, if we pose this way out, so do we have to put some alerting or some monitoring machines, something that this error pops up,
So
or
you
how
are
do
talking
we?
about the evaluation, which will again come
Yeah.
to it. Okay, don't worry about it. There is a lot of things to learn. Yeah.
Okay.
Yeah.
Sachin, in this case, like we use chunking by title. So let's say like if we have used the semantic chunking, so do we get like a difference in the output or
You
that
will
will
you will
also work?
get you will get yes, you will get some difference in the output. Ideally, I mean, this is a good question, by the way. I mean, you just try it out. Okay. I want to also see. So it depends whether this chunking by semantic chunking is giving you a good result, or chunking by title is giving you a good result. So I would suggest, just try it out. But my way opinion over here is, see, in the title, when we say chunking by title over here, if you have some, data which is associated with table and images, and if it is coming into the same chunk, we are going to have it in the same chunk. But semantic chunking won't be able to understand whether the table information should go where. So I mean, you have to write a custom code also on top of that, that let's say once you extract all the images and table first, having some top data and below text data associated with it, and then when you are sending it to the LLM, you can always say that you have to combine this information with the appropriate chunk, right? So
Hmm.
that glue code you have to write, but it's a worth giving a try. I haven't tried it on that part, so I cannot comment that which one is gonna give you the good accuracy. But this is how, like, any an AI engineer will think that why not to take this strategy also which you have come up with, and why not to test this in order to check, okay, which one is giving a good accuracy.
Yeah, because I'm thinking like, because like when usually reports are written, so there are some specific useful tables that are put into the appendix in the end of the report.
Mhm.
So if those are left behind and those are not associated with that particular chunk, so how it will going to connect? So is
So
there?
that's what I told you. Try it
Yes.
out, give it a
Yeah.
try. You will automatically get the understanding on like which one is performing well.
Okay. Yeah.
It depends upon different documents, and that's why you say whole of the thing is it's a part of data science, right? Ultimately,
Yep.
so data science
Yep.
is all about experimenting.
Yes.
Yeah.
Okay. Yep.
If you have a two very clear path, good path, then experimentation will basically give you answer to which.
Clarity. Yeah.
Yeah.
No. Yeah. Okay. Thanks.
Okay. Any more questions, anybody? No questions? Fine.
So,
Yeah, yes, sir, first, go ahead.
yeah, so my question is, right, since here we are using PDF, right?
Hmm.
So based on, right, what document we have, we are deciding this chunking, right? What chunking we are using, like title or something.
Hmm.
If we have HTML, it will be like different, like HTML header or some
So
chunking
HTML will be very well can be converted into a PDF, right?
PDF.
What do you think?
Yeah, but
Yeah.
directly if we referring, right, like
See,
pages and
HTML, it depends upon your use case. If
okay.
you are referring or directly HTML,
Mm-hmm.
then you are more interested in code part of the HTML code, COD
Mm-hmm.
code. You are not interested in the actual content, how it looks like, right? Because if you are referring the HTML, but if you are more interested in the actual output of the HTML, then you see HTML can be very easily converted into PDF, and then you can use the same pipeline.
Okay.
Yeah.
My question is also related to chunking only, Sachin. We have learned about this thing, right? What you call it? Text, character text splitter,
Mm-hmm.
right? Recursive text
Mm-hmm.
splitter. And then also one more semantic splitter. And here we are using
Chunk by title.
chunk by title. So uh, the previous whatever we have learned, that can also be used here as a chunking technique.
I would say, apart from semantic or agentic one, uh, rest of the chunking techniques, you use it only for the text data. But if you have a multimodal data like this one, don't use those.
Oh, okay.
Yeah.
Okay.
Any more questions? Anybody?
One last question, Sachin, from my side. Suppose,
Mhm.
for example, for images of our tables, we have large chunking size. Would that, reduce the accuracy or some kind of thing? Because again, the
Experimentation. I would say experimentation. Sometimes I have seen if you have a decent size chunk like 5,000, something like that, sometimes it increases the accuracy, but sometimes, I mean, since we have a freedom to increase the chunk size, it does not mean that you just keep increasing the chunk size and you can expect a very good accuracy. Sometimes it will reduce it also. So that's we have to find a very sweet spot of the basically chunk size. That's it.
got it. I know it's but experiment only, but is there any way that we can, okay, you'll cover in evaluation, I believe, later
Yeah,
on
in
that.
the evaluation, yes, we are gonna do it. Correct.
Perfect, perfect. Thank you.
Okay, so let's do one thing. I'm gonna just run the same code by changing the LLM and let's see what will happen. Let's go to the LLM. Oops. Hmm. Hmm. This is fine. Only thing is this one. LLM. Okay, let's call this LLM only. Second. Okay, let's see if it throws any error. We'll see. It's a little trickier. That's why I have to run one by one. Otherwise, something can break. So let's go slow only. Okay. All right. Okay. Now this is the code, right? It's working fine. One error came. One validation error. Input type list. Input should be a valid string. So the model which we are using, it's not a LLM model. Sorry, it's not a multimodal model. Let me just quickly check this. It's a multimodal or not. It's fully multimodal, text and code, image and screenshot, video files. It is. So if it is, why it is not supporting this? Yes, it can support text, image, video, and everything, which is great. No problem. Let's fix this quickly. Cell number 43. Getting the validation error in cell number 43, I'm using a Gemini Flash model. Can you please check why this error is coming and try to fix it? Document construction, Gemini response type locally, then patch the notebook. So LangChain document always receive text while multimodal content is these. Okay. We were sending a LangChain document and that was the problem. Let's try this now. Added a function definition exit clearly. The next check is the original failing processing cell, which Gemini list shape response in the converted before document is instantiated. Okay, let's try this. It's running already. Cool. Yeah, you see it worked this time. It is now working. Only the problem was we are directly sending the LangChain document and Gemini model was seeing it as a text instead of the because multimodal content was present inside that document. That's the problem. I fixed it. Now let's move ahead. Okay. And let's run this one. And now we got the changed JSON file. Let's see. Chunk number 5. Yeah, you see now this is searchable description and this is the description. So all the reasoning trace has gone now. If you, in fact, if you don't put this searchable description, you can set the prompt in such a way that your LM should not give this searchable description. So you can say no fences like this kind of trading and before any kind of extra things. But this looks good than previous one. If anybody disagree, then let me know. Because now we have removed a lot of noise actually. Earlier it has a lot of reasoning noise also. Fine. Okay, so let's go ahead and create the database. We got the error. It says unable to open database file. Why is that so? Um, Database error, return code for unable to open the database file. Okay. No, actually, this was another database. Let me delete this one as well. Let's create it once again. Hmm. This is weird. Okay, it actually require a folder already should be existed. So let's do one thing. Let's create a folder called db and then try to run this. Hmm.
Seems VS Code is not refreshing properly.
Yeah, that could be one of the other reason. Let's do one thing. Let's just restart the VS Code itself, and what I'm gonna do is instead of running all of this, I'm just gonna click on run all and just wait. Okay, let's see what will happen. Because we have already made the changes, it will take some time. Now, till the time this is running, let's keep moving. And let's talk about, the retrieval methods also. So we have seen the multimodal RAG now. And by the way, this is one of the way, one of my favorite way I have taught you. But there is even more advanced way, which we are of course going to talk about. But first of all, let's talk about, some now even more advanced concept in the RAG, which you will, maybe gonna use it in your production systems. So first of all, I want to talk about the retrieval methods. A lot of you guys already knowing this, that whenever you create, a chroma vector database, so the way we are retrieving, or any vector database, currently the way we are retrieving it is in this way, that we are just providing this search KW arguments, keyword arguments, and we are passing that we need to retrieve three top most documents, relevant documents, and our retriever is gonna give those documents whenever a user is gonna ask any kind of query. So this is one way of retrieving the documents from the vector database. Now there are other different ways also. So let me just do this. Other way is, now let's say, you want to set some kind of threshold that you only want to retrieve documents which is having some similarity score greater than some point. For example, in this case, you see, you can pass one more parameter which is called as score threshold. So here it's not only going to give you the first three documents, but it will also check whether the document is having the threshold greater than 0.3 or not. You can set it to 0.7. It generally ranges from 0 to 1. Now, let's say if you set this to 0.7, and for your query, if the documents are only two documents are there which is having score greater than 0.7, then you won't be able to get the three documents. Even though you have set the k as three document, you will only able to see the top two documents, but those are very high relevant documents. So we have you can also play with this parameter score threshold. Okay, and this is also kind of hyper parameter. We have to find a sweet spot whenever you are building a RAG system. Okay, so that is another way. Then there is third way also, or you can say there is a third technique also. This technique is called as MMR. Okay, MMR. MMR is a technique which stands for maximum marginal relevance. And the way you are gonna use it is in this way. So let me uncomment the code. Same in the search KWRs, you are gonna provide K, but apart from that, you will also provide this fetch K and lambda multiplication factor. And in the search type, now this is going to be your strategy MMR. Now let's try to understand the how MMR is different than your normal similarity search. So the purpose of MMR is basically, to maximize the information diversity into the search result by, preventing repetitive or redundant text from reaching the AI. It works by picking the most relevant chunk first, then selecting subsequent chunks only if they bring new unique details compared to the ones already chosen. What does that mean? So MMR, it's a little bit sophisticated algorithm. There is a research paper also available on the MMR. What it does actually, so let's say you have set a k value as 5, and while retrieving the document, it is first gonna, let's say, found some kind of document which is having the some very high threshold. It is gonna retrieve that, but then it is gonna compare word by word with other documents, and it is gonna retrieve other documents only and only if those documents are having some unique set of information. Otherwise it will leave that document. It is not gonna retrieve that. Now in my personal experience, I have found MMR is best when you are building a RAG system where your documents are very your data is basically very spread across the multiple documents. Okay. In that case, MMR is useful, but if you really want to do a narrow search, MMR basically will fail miserably. And you, instead of, because you see the whole purpose is what you need to extract the relevant chunk, right? But MMR beat that purpose because it will always check, okay, let's say if a document one has extracted, but if document two is talking about the same thing, MMR will not take that. It will check is in that document, is there any new information is present or not? And it is only going to pick those document if the new information is talked about. So, but it was built for basically, if you have information spreaded across the documents, in that case, MMR is basically useful and you can use this particular technique. We don't want to go into the mathematics of MMR because there is a whole algorithm for it, how it does actually. But this is a technique which exists and this is how it basically works. Okay. Now, these are the parameters like you see, K is maximum number of documents. Basically, you want two. Now, fetch K means, so when MMR is gonna retrieve the document, so it will first create the pool of document which it thoughts that for a given user query, all of these documents are having some kind of additional information, or you can say different information. So it will always create a pool of documents. So you can set that. So here it is set to 10. So it will check, okay, this document is here. Now in the other document, is there any additional information? If yes, let's include it into a pool. Otherwise, let's not include it into the pool. Then goes to the next document. Okay, check whether this document is having some kind of different information than this document. If yes, include it into the pool. Otherwise, leave it. And then it is going to create the pool of 10 documents. And from those 10 documents, it will finally going to give you the 3 documents. So these are your final number of documents which you will receive. But from how many documents, it's going to basically curate the pool and then going to give you the answer. So that is the fetch key. There is something called as lambda multiplication. Now this is coming from your algorithm. When you set 0, it has a 0 to 1. 0 means max. And when you set 0, that means you don't need a very same information. You are looking for very distinctive information. If you set to 1, it will start working as your similarity score. So now when you're going to set to 1, this will not have any difference than your similarity score. It is start acting as a similarity score. That is how the formula is designed for the MMR. Okay. So that's a lambda multiplication factor. Okay, so these are some of the techniques which we use while retrieving the document, and these are the only parameters which you can play with or set it as a hyperparameter while extracting the documents at the retriever side. Anybody have any question on this? Or clear?
Sachin, can you give us some example about how the data diversification would be there for maximum marginal relevance? Any example so that it
Sorry,
can.
what's your question?
Can you give us any real life example that, okay, this is the diversity, this is how it comes up?
So real life example could be, uh, I have not seen any such use case, but sometime it can be useful. Let's say if you have, let's say you are dealing with some kind of maybe financial document, and of course I'm just thinking, I have not worked on this use case, but let's say if you are having a kind of document like maybe financial document or maybe medical document, where when you are going to ask a query, the answer will not depend on one focus place, but maybe you will have your answer can be distributed in different places. Okay. And if you already know that, okay, this is the going to be the case, in that case, maybe MMR will be helpful for in that situation. I have not seen those actual use cases, so I won't be able to comment more on that. But this, whenever there is this kind of case, I know that okay, let's directly start with the MMR, because MMR is basically built for those kind of use cases. So if you have any kind of documents which you already know that okay, the answer is not gonna be concentrated in one place for my query, rather it will have on a 10 different places or 5 different places, then start with the MMR.
So if I just expand a little bit on the medical example, right?
Mhm.
Suppose in the medical, we have all the history of the patient, and suppose he has certain kind of migraine and he complains regularly. But suddenly some test comes up and we documents all the relation, right? I mean the LLM that previously he has the history of migraine. Now connect this with this, the latest one, and now
Mhm.
let's try to see the relevance. So
Mhm.
that way it can get all the details, and then probably the reasoning model can work on the diagnosis. Something on those short.
Kind of, but it is not. MMR is still not coming into the picture, because when you talk about RAG system here, uh, you have to create the vector database also, right? And when you know that okay, in the given document, maybe any kind of document, medical document or any document, when you know that okay, answer is gonna be available in a far like pages, it's not gonna be concentrated in one place. So in that scenario, you just go with this MMR. Now I cannot think of any use case, because you see it's totally a very focused use case, right? And
Okay.
if anybody have worked on this, I would love to heard their opinion. Otherwise, you just have to wait, right? And wait for the opportunity. Whenever you get this kind of data, you can apply this.
Excellent. Makes sense. Thank you.
Yeah.
Sachin, I think one of the example I can say, let me know it's coming under this or not. Suppose if you have to, create a exam paper, you can say, let's say an IIT. So you have to, get the contents from PCM maybe, right? So physics, chemistry, math. So books can be considered as a different source, and the exam paper can be considered as a, final MR topic, right? Because the source is coming from different background, right?
See, source is coming from a different background, but the thing is, let's say you talk about only maths right now. Let's say if user ask a question on any topic of maths, maybe let's say he's asking, okay, let's talk about derivative, and within the derivative, let's user ask this question, okay, what is going to be the derivative of this? So the answer for that is going to be present in one single place, right? It will not present in multiple places. One answer will not be available on page number 1 and then page number 100. That is not going to be happen, right?
Yeah, exactly. Yes.
Yeah. So what I'm trying to say is, within your document, let's say your answer is available on page number 1 as well as on page number 100. You see, there is a huge difference. So in that cases, since MMR is gonna not just take the similar documents and then just gonna give you the output, it will check that is there any new information associated with that question is coming in any chunk, present at any page. So it's gonna look in that way, and then gonna give the answer.
Okay, now understood. So don't you think it will be like really slow? Because one chunk will compare, suppose we have 100 chunks. So one chunk will be compared to, I mean, till 100,
It
getting
is
the
little slow.
score.
It is little slow, but it's not like it will be too much slow. Ultimately, it's just working on the formula. It is just comparing. That's it.
Ah, okay.
Yeah, but
Understood.
yes, with respect to similarity search, it will be slow. You are right.
Yeah, got it. Thanks, sir.
I got little confused here, Sachin. Uh, um,
What
uh,
computer?
the retrieval method is something we are talking about here, uh, fetching the chunks which is more I mean more relevant to the question, right?
Mhm.
And and MMR is something which avoids the redundant result.
Not fully avoid the similarity. It just basically try to find it out the new information. If there is no new information in the new chunk, even though it is talking about the same, I mean, similarity score can be very high. But if there is no new information with respect to the user query, apart from the earlier chunk, it is not gonna take that chunk in the output. That's what MMR does.
Okay.
But let's say if you're directly applying a similarity score, one document is talking about the same, second document is also talking about the same. It is gonna pick that.
Okay.
Yeah.
So that's one second. Okay. That's
Okay. Thanks, Raj. Thanks for that. Actually, that's my job, so I have to take it. Fine. By the way, we have run this, and let's see, we are getting some errors. Let's see. Okay, we got our vector database ready. This 33 chunks also got processed properly. All right. So, okay. Answer. Okay. Here we are using still the Grok LLM, and we need to change that with LLM. So, of course, it will fail. Now, let's ask this question again. And there you go. Uses 8 parallel head attention. You see, this is pretty much good answer. You see, you don't have any reasoning and those things. Finally, you have the direct answer, right? You see, and we are not getting the any error also over here because we are using the paid APIs. Of course, it will not give any error. All the 33 chunks are created properly. You see? So this is also clear. Let's keep moving. Now, from here, what we have to do, we have to, understand we have understood the basic RAG setup, but now onwards, what we are trying to understand is basically how we are going to improve the accuracy, okay, of the RAG system by applying multiple strategy. Now, till here, when I ask any data scientist or any AI engineer, okay, what are the different strategies you are going to follow in order to improve the accuracy of your RAG? They have this already answer known, like MMR, or like putting the threshold score, and this is for, of course, at the retrieval site. And while these are very good techniques, but still in a lot of use cases, or you can say this start failing, and you should have the idea on other advanced technique also, that what else you are going to do in order to basically improve the accuracy of your RAG. So these are not only the limited techniques, these are good techniques, but we should have, like in the RAG, a lot of researches has happened, and we should be knowing those parts as well. One of them is called as a multi-query retrieval. Let's try to understand what does this mean, and let me just quickly change the first embedding model over here. Okay. Hmm. Guys, please be muted. Now let me quickly, run this first ingestion pipeline, because we are gonna understand the remaining concept on this one itself. So see RAG for beginners, UV run one ingestion pipeline. Yeah, so it is creating the vector store. Now let's come to the multi-query one and try to understand. Okay, so what do I mean by the multi-query one is, in this particular technique, what we are gonna do, as the name suggests, it's a multi-query. So sometimes, uh, whenever you are gonna go for the retrieval, see, user can ask a vague questions also, right? User is not gonna be very much clear on their document at each and every point of time. Now, if user is really asking, let's say you are dealing with financial document, user is asking what is coronavirus. Now, when they ask this question, they are definitely gonna get some kind of answer. Why? Because ultimately what you are doing, you are just comparing the vectors. And even if the threshold score, similarity score is set to 0.0001, they're gonna match, right? Let's say if you are setting the threshold is, let's say, zero point 0.5 or 0.6. In that case, of course, you will not get any document if similarity is not there. But in that case, you will get a blank document. Now, since you're gonna get the blank document from the retrieval, later on when you are going to send it to the generation pipeline LLM, you will get what? Your LLM will say, I didn't receive any document, so I am not able to answer this question. Now, this is a good thing, right? Because your generation is giving you the proper answer. But let's say if the user is asking same thing, like related to financial document only, but which is not present in the document, or maybe some very vague question related to finances, which is not too much clear. In that case, this particular technique will come, and which is gonna enhance the user query. Now, the same technique is used by chat gpt also. So whenever you are gonna ask some kind of query onto the chat gpt, they don't directly take your query. If it's a vague query, it try to break down your query into more meaningful data. Or if you have used Cursor, Windsurf, or any kind of agentic tool, I mean, you have must be using all of them. But let's say if I open this Claude desktop, right, and if I ask a query that, okay, I want to maybe build some kind of website, can you please go ahead and create one for me? This is a vague query, right? Because you didn't tell, okay, what kind of website you have to create, what specific information you are looking for. So in that case, what will happen? Your LLM is basically gonna take the query and basically break down. So sometimes based upon your history, it will able to understand, okay, since user is maybe familiar with JavaScript or maybe Python, let's create the website in Python, something like that. Or maybe user is asking some generic, so let's create the website for his portfolio, or maybe whatever based upon your interest, based upon whatever chat you have done, it will just create one, right? So this kind of technique we also use in order to enhance the user query while retrieving the answer. So sometime it might be possible that user is asking something which is vague, and by using this method we will be able to expand the user query, and we will be able to fetch lot more meaningful chunks. So for example, here you see the user is asking how does Tesla makes money? Now this is a valid question, but there is a technique you can enhance this question. So you can use the LLM. Remember, we have seen this function method called as with structured output, where we can enforce the schema and we will be able to get the answer. And with the simple prompt, what I'm saying that just generate the 3 different variation of this query. Okay. That would help retrieve relevant document and return those 3 queries only. And I'm enforcing this schema called as query variation. When you see this query variation, it is just a list of queries. So finally, LLM is going to give you the list of queries, right? So at the first stage itself, we are using the LLM in order to generate 3 different variation of the query. So let's say even if one query, which is the original query, which is this one, how does Tesla makes money? If we, in any case, in any scenario, if we are not able to fetch the relevant documents, maybe it's subsequent queries or the variation of the queries will gonna help us to finally get the relevant chunks, if we are gonna try it out. So it's like take the single query, break it down, maybe 3 variation, 5 variation, and cast a very wide net on your vector DB. So initially, let's say if this query, we have set the top k documents to be 5. So with this query, we were only able to get the 5 initial documents from the vector database. Now, there is a possibility that it might have the answer, it might not have the answer. But when you are gonna generate the variation of these queries, so then you will able to get the 15 documents. Now, I'm not saying that those 15 documents will gonna be unique, because the query is gonna be variation of the same query, right? Those variation query is gonna be derived from the original query. That means it will carry the semantic meaning. So maybe for this query, you will get the 5 documents. For the second query, you might get 2 new documents. And for third query, you might get another 2 new documents and the 3 previous documents. So maybe 4 new documents you will be able to get. And now we will have the 9 documents, okay, instead of 5 documents. And maybe with those 4 documents, we will end up having the answer for that user query. And that's the benefit of this particular method. Now, again, here we also need to find it out the sweet spot. It's not like you can keep generating the variations of the query, because if you are generating the lot many variations of the query, that means you are increasing the complexity layer in such a way that it has to fetch a lot of documents. And because you have a lot of documents, now you have to basically compress it. By the way, there are different ways to do that, but a sweet spot is like 3 to 5 variation of the query, not more than that, depending upon the how complex is your data. If you have a really complex data, by the way, we are going to see those complex data right now. I'm just showing you one single PDF. We are going to do that over there. Okay, let me just show you right now. We are going to work on that data. Yeah, this is the data. So you see, this is the financial document of the short bank DB. You see, it has this entire document, and it is almost around, I don't know how many pages. And you see, it has this complex tables as well, right? Now let's keep going. It has almost around 600 of pages, right? Similarly, we have this EY financial report. Okay. All right. So you see, this is a kind of data we have in this graph format, table format, these kind of pictures, right? And we have to extract these information now. So you see, this is going like a balance sheet, right? So we are going to deal and build a RAG system on this also. Similarly, let me show you one JP Morgan data also. You see, this is a JP Morgan annual report. You see, if somebody asks a question, okay, what was the maybe net income on in 2023, or sorry, in maybe 2018. Now, net income is shown by this particular notation, right? So in 2013, where it is, I don't know. Anybody able to answer? In 2013, what was the net income? I think it is shown here, right? Or maybe if you talk about diluted earning per share, so it is like 2.354 and $4.33, right? So these are diluted earning per share. Similarly, like these kind of documents are kind of hard to get the answer. But you are gonna see we will be able to parse this document and we will be able to get the proper answer on these kind of documents also. Okay. Yeah, these kind of complex tables also we will be able to get the answer. All right, so that was the data. Now let's come back over here. So I mean, generally it's a good idea to create a variation, and with this variation we will be able to basically hit our vector DB and we'll be able to get some more information, so that there is a chances that we will end up having the answer on those extra documents which we are fetching. And how we are going to do it? Simple. Just create this kind of pedantic schema. I'm sure now you must knowing what is pedantic schema, and just send the schema to LLM so that we will be able to get the structured output. That's it. And finally, LLM is going to give us that query, and then take that query, hit the database for those three queries. So you see, we are iterating through this all the query variation, and we are invoking the vector database and getting the result. That's it. Let's try to run this and see. Before we do that, let's change the LLM once again. Now here you can use a simple LLM, not a problem. So I'm gonna use this, our Grok LLM. Okay. And you see, why I've run this ingestion, because we are going to use this particular, if you remember, we have these documents, Google, Microsoft, NVIDIA, these documents. That's why I created the database once again. So I'm loading that vector database, and we are going to query on that particular vector database itself. So let's try to run this and see what we get. Okay, is not found for API. That's a weird thing. By
Did
the
you
way,
change the model?
sorry,
Did
Siddharth?
you change the model here, embedding model?
Yeah, I will check that. But by the way, you see, so these are our generated query variation. What are the Tesla's primary revenue stream? How does Tesla generate its profit? Which business segment contribute most to Tesla's earning? So it's a same query with little variation, not too much variation. Okay. All right. Now let's see why we are getting the answer. So Gemini model embedding 001. That's the problem. This model is not named like this. It should be like this, Gemini embedding 001. I have not given the proper model name. The model name is Gemini embedding 001. And now it will work. All right, it worked. And you see, for result for query one, what are Tesla revenue stream and how does company generate profit? Now this time you see question got changed because you are using LLM, and of course LLM will every time generate something new. So these are the 5 document. Document 1, the quarter ending June, this Bitcoin. I just printed, couple of starting sentence from the document. As you can see over here. Just starting 150 words, not more than that. So so let's talk about this one. Government pollution standard, that number has this. You see, this document is not talking about the uh, revenue stream. By the way, let me do one thing. Instead of printing the first 150, let's print the entire document itself. Otherwise, we will keep guessing. All right, now let's try to see. So document number 1, government pollution standard, smaller percentage of revenue for multiple quarters, automotive 87.6. Yes, it did talked about the percentage of revenue. Energy generation, this. United States is this much, fine. Document number 2 talks about the quarter ending June 2021, year-wise revenue income, fine. 2005 this much, 2006 this much, fine. Document 3 talks about Tesla. Basically, it talk about when Tesla incorporated and those things. Document 5, Tesla sold 2 million electric car, but it does not have any. Okay, here is we have the financial part. So you see, we are able to get a lot of information for this query. And this is the document number 5, total equity, it's as given over here. Now, if you go for the query number 2, how does Tesla generates its income and profits? You see, this document we have seen earlier also, right? So this is the same document. Elon Musk took an active role. Have we seen this document? No, we have not seen this document earlier. It's a new document. We have seen this one also earlier. Government pollution was also there, right? So you see, some of the documents are coming new, but some of them are older document. Similarly, for query number 3, government pollution, this again we have seen this document. Document number 2, the quarter ending June. Yes, we have seen this one. Tesla Inc., that is also has been seen. Tesla was incorporated, that is also been present. as of Jan 2023, Tesla offers insurance. I think this one is in the energy product. We have not seen this document. Elon Musk took active role. This one was also seen, right? Total equity US. All right. So you see, these are the different documents were fetched from basically generating the multiple version of the query. So this is one way. It's basically casting a wide net so that you will have bunch of documents. And then it's not like you are going to directly send this document to the final LLM. No, that's not how it works. We have a lot of other methods, which I'm going to show you. I think we can stop now. But there are 2, 3 more techniques we have to cover. There is something called as reciprocal rank fusion. There is something called as hybrid search. There is something called as re-ranker. We are going to combine all of this thing, and that will give you a more robust idea when you are creating a retriever. If anybody have any question, they can ask. We can stop over here for today.
Sir, regarding the search, what you give is right now you're seeing through PDF, but if you have a combination of Excel, PDF, and Word doc, will it generate the output?
Yes, you have to write a pipeline for that.
So for all the three types of formats of docs.
Yes.
Because you say
LangChain supports it.
Mhm.
You can do that. Yeah.
Because generally in actual scenario, the finances are given Excel. The content is written in PDF or Word.
Yes, you're right.
But when as we have an option of giving query, we will ask both questions in both where we expect answer to be in text and numerical values.
Right, you are right. And by the way, from this, I got one. I remember where MMR can be used. So it's a good idea actually. Let's say if you have an Excel file, if you have a PDF file related to finances, Excel file is, let's say, related with this another document. And while you are generating your chunks, you don't know, like Excel chunks will be present at which chunk ID, and then this PDF chunk will be stored at which chunk ID. In that case, MMR will be helpful. And coming to now your question, will this work? So this, you have, as I said, this code will fail because we are not handling the Excel reading and those things, right? You have to write the custom, basically, LangChain, by the way, supports it, but you have to write the pipelines for it in order to support the PDF, Word, Excel files, CSV file, all of this. Okay.
So we can give a mixture of these formats of document.
Yeah, you can give it. You can give it. We have built that kind of system in our company. You can do that. Just learn all of this concept and then combine it. Because it's not possible to cover for me each and every scenario, right? Something you have to also explore from your end.
So, Sujina, I have a question. So for when you're building, because I work in a financial institution over here in my country, and some of them are scared of exposing their data to LLMs, thinking that they are sensitive data from the bank. So which approach can someone use to
Yeah,
build a
in
RAG
that
pattern?
case, you have to go for the maybe SLMs or fine tune some kind of small language model, or just host it LLM in your server. Don't use this kind of closed source LLM. Use any open source LLM, deploy it via maybe VLM engine. We are gonna do that fine tuning on a later stage. Okay.
Okay, so the best approach is not to expose it to the normal LLM, right? To
Yeah,
provision it in the
if you have the problem with data going to be out, then you of course you can't use those LLMs.
Okay.
Yeah.
What about the scenario when we are having the reports in some dashboards like Power BI or Tableau? Can we connect to?
Write the connector. Write the connector. There is a Python code. You write the connector to connect that dashboard. Fetch the data. Use
Okay.
it.
Yeah, we can have the connectors, right?
Yeah. There are already connectors like Python connectors. You can connect data to Power BI, Tableau, Azure databases, Cosmos DB, a lot of other databases. You just have to write the connector. That's it.
Okay.
Yeah. All right. Anybody have any more question? All right. So thank you for joining, everybody. I'm gonna post this code.
Sachin, when is the agentic class starting?
After finishing this RAG one, right? All the concept of RAG which is remaining, I think we are gonna start the agentic part only.
Okay.
Yeah.
I'm talking of your next class. I think you have an agentic class to take in.
Okay, that one. That is starting from 31st August, actually.
Okay. Is it project based? Abi theory and project.
Sorry?
Is it project based? Abi theories and project.
We are gonna build some projects, of course. Here also we are gonna build it.
Okay.
Yeah. But it's not like I can build each and everything, right? It's just a 3-4 month class, right? If you expect me to build 20 projects, that's not possible, right? Everyone has their unique set of requirements. So I just have to, I can show you a few scenarios. As an AI engineer, you have to evolve and learn other scenarios. But the best technique which I know, I'm gonna share with you.
Okay.
Yeah. Okay, so I have committed the code. You guys can just go through it and let's meet tomorrow. Can't push refs to remote. Try running first. Okay. All right. Thank you for joining. Good night, everybody.
Bye bye, Sachin. Good night.
Okay.